All right, this is our second lecture, chapter 4. It's a continuation of solving by taking the square root. There's a lot of different ways to solve quadratics. Taking the square root is one of the simpler methods. We're going to continue today with a process called completing the square. This is used to solve any quadratic regardless of how complex it is. What it does is it simplifies the algebra so we can get an answer pretty quickly regardless of how complex the answer is, real or imaginary. So today we're going to focus on the algebra end of it, and we'll work on this for a couple of days probably. So let's first look at a couple examples here just on how to, again, take the square root, different scenarios. So the first one here, problem number 1, we want to get x squared on both sides. And then we're going to move the 1 over to the other side. So over here we have 1 is equal to 2x squared. And then here what we have is, if we divide by 2 on both sides, cancel, and we have 1/2 is equal to x squared. We learned yesterday that we need to take the square root, and again, plus minus. And what we have here is 1 over the square root of 2, because the square root of 1 is 1, and the square root of 2 on the bottom, you can divide it up as it is, equals x. Now, again, we don't want to have a radical on the bottom, so what we do here is we multiply the top and bottom by the square root of 2. So I'm going to put that over here, top and bottom, square root of 2. And we're going to have on the top the square root of 2. On the bottom, simply 2 is equal to x. And again, plus minus, don't ever forget that. So that's how we want to do that. So that's, again, rationalizing the denominator. We'll see that here a little bit later as well. Number 2, again, we want to get the parentheses by itself, so we divide by 2, and we're left with x minus 3 quantity squared is equal to 4. Again, to undo that square root, we use the square root, I'm sorry, and again, plus minus. So we have x minus 3 is equal to plus or minus 2, because the square root of 4 is simply 2. Now when we move the 3 over to the other side, our answer is really x is equal to 3 plus or minus 2. Now again, you don't want to leave your answer like that because this really means two different answers. So I'm going to draw them off over here to the side. We have x is equal to 3 plus 2 and x is equal to 3 minus 2. Well, obviously this first one is 5 and the other one is just simply 1. So the answers are x is equal to 5 and x is equal to 1. So there's, again, our two answers. So they're not identical twins, but notice the setup was, and we could follow through because they're both simple integers here. Okay, so we'll see problems like that as well. Okay, question number 3 down here is simply this rationalizing the denominator like we did in problem before. I'm just going to show it again because it comes up a lot. This could be switched into the square root of 6 on top and the square root of 5 on the bottom. Again, we can't have a radical in the denominator, so we multiply by that radical. And in the top, we have the square root of 30. And in the bottom, we have simply 5, and that is considered a proper answer for that problem. Again, not having a radical in the bottom. Number 4 is very similar. Let me scroll down a little bit here so we have a little more room. And again, we're going to multiply by the conjugate. Now again, the conjugate, let me put that back, move there. Conjugate is simply the exact element. But instead of a minus, we're going to change it into a positive. And I do it to both the top and the bottom. So x plus the square root of 3 on the top. Now, by doing this, they're identical on the bottom. One's positive, one negative. It's going to get rid of that middle term, which happens to be radical. So here on the bottom, we're going to have 8 times 8 is 64. And then we have negative 8 radical 3 plus 8 radical 3. And the last term is radical 3 times radical 3, which is simply 3, positive times negative, which is simply a negative. Notice the middle terms cancel each other out, and we're left with 64 minus 3, which is simply 61. So that is our new denominator. Then on top, we simply just distribute. 4 times 8 is 32, and then we have 4 times radical 3 is just simply 4 radical 3. So on top, we have 32 plus 4 radical 3. And we have to look, is there anything reduced? Not in this problem. So that is our finalized answer. Again, not having a radical in the denominator. So that is how you rationalize those problems, both 3 and 4. So either using the square root or using the conjugate. Very similar to complex numbers. All right, so that's just kind of a little warm-up. Let's move on to today's lesson, which is called completing the square. Again, this is used as if we have a problem that's a little complex, how do we simplify it by making it a perfect square root? For instance, the square root of 4 is 2. Nice and simple. Whereas the square root of 5, ugly decimal. So we can't do that. So what we have here is a pattern. Notice if we have x plus 3 quantity squared, and I expanded that, that's really x plus 3 times x plus 3. Well, when you FOIL it out, you have x times x, which is x squared, then x times 3, which is 3x, and then another 3x, and now you have a middle term of 6x. So it's the middle term doubled. And then the last term, obviously, is 3 times 3, which is 9. So this term over here is squared, and this over here is doubled. Okay? So that is the pattern. So looking at the next one, x minus 4 quantity squared, well, you double the 4 to get negative 8, and then you square the negative 4, and you get positive 16. So let's go ahead and just fill in these next couple ones. X plus 8, I'm looking here right now, is simply going to take the 8, double it, and you get 16x, and then you square it, and you get 64. And that's exactly what we have. Notice this last term here is always going to be positive. Okay? And what these are all called trinomials, because they begin with an x squared, followed by an x term, followed by a number. Okay? So there's 3 terms, and that's solely what we'll be working with. Look at the next one here, x minus 6. You're going to double the middle term, so it'll be negative 12, and then square the last term for a positive 36. Okay? If I just scroll through the last couple examples, I'm going to have simply x squared plus 18x plus 81, and the last one, x squared minus 10x plus 25. So notice, again, I'm doubling and then squaring. Looking at the other way, I can go backwards. So if I'm given a nice perfect trinomial that is a perfect square, I can split it up and then show it as squared item. And the nice thing about this is we can take the square root of nice squared items. So let's go ahead and take a look at this. Second example, what would this look like? Well, we know that's going to be x squared plus 8x plus 16, which is just simply x plus 4 squared. The next term here, x plus 10 quantity squared. You get that from the middle part. Then notice down here, what I'm doing is, instead of doubling, I'm taking this in half. So it's going to be x minus 1. I'm taking this b term, the term in the middle, and I'm cutting it in half. And in the last term, you're just taking the square root of. So notice, if I double negative 1, I get negative 2. And if I square the last term, I get positive 1. And that's how you work backwards. So let's look at the next one. Okay, we have x squared minus 4x. Again, let me just show you, again, the coefficients. This is, again, review. We have ax squared, that's your first term, minus, or I should say positive bx plus c. So now we're talking about this b term right here. So you simply cut that in half. And then if you square that term, negative 2, you should get positive 4, and we do. So it's a nice perfect square. So we just simply say x minus 2 quantity squared. Let's not forget that there. And the last one, cut in half, square it. 6 squared is 36, so it checks out. And again, we don't have to write that middle step anymore. We want to be able to go from a perfect trinomial to a perfect square right away. Okay. So again, just work on recognizing this pattern, and we're going to use this on these next steps. Okay. So if we have a quadratic like this, x squared plus 6x, what number can we put here that would make it a perfect square? Well, you take the middle term and you cut it in half. So you take b and you cut it in half. And in that case, it's going to be 6 divided by 2, which is 3. And then you're going to square it. And you're going to put that number over there. So 3 squared is 9. And again, what does this end up being? X plus 3 quantity squared is equal to this trinomial right here. Okay. So let's follow the same pattern here. I'm going to take the middle term. I'm going to cut it in half. So a b cut in half, which is going to be, I'll write it over here, negative 8 divided by 2, which is going to be negative 4. And I'm going to square it, which is going to be positive 16. So I'm going to have x minus 4 quantity squared. And that's what I'm looking for here. So we want to force this pattern onto equations to simplify it so we can get a nice perfect square. Notice the problem originally is not a perfect square, but by adding a number to it, we can make it a perfect square. So we're going to take that knowledge and move forward to this next step here. So these are the problems that we're going to have to be able to do. Everything we've seen is kind of a build up to this problem, and this is called completing the square. Notice x squared minus 4x plus 2. Well, if I went ahead and cut this in half and put x minus 2 quantity squared, and I fold that out, we have x minus 2 times x minus 2, and that's going to be x squared minus 4x plus 4. And notice we need a plus 4 for this to work, but we have a plus 2, so we're missing something. So how do we correct that? Well, this is how you do it. So I'm going to erase that and say, that's what we want to happen, so this is how we make it happen. First thing you do is you move whatever number to the other side. So I'm going to have x squared minus 4x equals negative 2. Get it out of the way. And I'm going to now put in that blank. Now, in fact, I'll put it in a different color so it kind of stands out. So if I put a blank on the left-hand side, guess what? You need one on the right-hand side. Because whatever you do to the left-hand side of the equation, you need to do to the right-hand side. Now, in this blank, I'm going to put in the number I need. So again, I'm going to take the 4, I'm going to cut it in half. So this would be b divided by 2, and then squared. And that's going to go over there. So I'm going to have x minus 2, and I'm going to square that. And this will produce that number of positive 4. So now we have a perfect trinomial, x squared minus 4x plus 4. And the square of that is x minus 2 quantity squared. So if I add 4 to one side, guess what? You have to add it to the other side. So now we have simply x minus 2 quantity squared equals, and simply just combine those two elements together. Negative 2 plus 4 is positive 2. And now it's a simple problem that we can solve algebraically. And this is like our warm-up problems. How do you take the square root here? Well, just simply like this. Positive, negative. The square root of something squared is that element by itself. And we have positive, negative square root of 2. Move the 2 to the other side. And we simply have x is equal to 2 plus or minus the square root of 2. And we got ourselves a nice, clean answer. Now again, 2 plus or minus square root of 2, square root of 2, that is a complex answer. I shouldn't say complex because it's not imaginary, but it's irrational because it's got a decimal that goes on forever. But notice how we're able to get it very easily, algebraically, with this system. Okay. So that's the first example. So let's show another one here. And I'll kind of just go through the steps and talk a little less here. So again, notice the numbers already moved to the right-hand side. So that's good. So I'm going to have x squared plus 6x plus a blank equals 16 plus a blank. So now, what number goes here? Well, I'm going to take the 6 and I'm going to cut it in half. And then I'm going to square it and put 9 in that spot. If I put 9 on the right-hand side, I'm going to put 9 on the left-hand side. So the left-hand side's already done. The right-hand side, 16 plus 9 is 25. And now I say, all right, how do we solve this problem? Well, you simply just take the square root of both sides, plus or minus, and we simply have x plus 3 is equal to plus or minus 5. Well, piece of cake, move the 3 over to the other side. And we have x is equal to negative 3 plus or minus 5. Now again, we need to yield two answers here because those are nice clean numbers. Negative 3 plus 5 is positive 2. And a negative 3 minus 5 is negative 8. So we have two possible answers for this solution. Okay? And again, you could take any of these numbers and plug it back in the equation. 2 squared plus 6 times 2 should equal 16. And sure it does. 4 plus 12 is equal to 16. Okay? So that is completing a square. So notice it works for any problem, even when we had irrational answers or when we have a nice simple answer. And there's other ways to solve this problem, but the good thing is completing a square will always work. So here's the last problem. Now this one is, notice the leading coefficient doesn't equal 1. So the A position right here, notice that is not a 1. So what we have to do is force it to be 1. So again, the first thing I'm going to do is move the 30 to the other side. So I'm going to have 2x squared plus 4x equals 30. I'm simply going to add a blank to both sides. But before I add a blank, what I have to do is, so again, I'm going to ignore this stuff for right now. And what I have to do first is recognize that this 2 is in the way. So I need to take the 2 out. So I'm going to factor a 2 out. And we have x squared plus 2x plus blank. So now I'm going to look at the blank. And again, I put the x there because a lot of students want to put that there, but you can't do that quite yet. You have to factor the 2 out. And notice when you factor it out, you have to take it out of the first term and the b term. So if I distributed the 2, you would, again, get 2x squared plus 4x again. Now, what number goes in the middle? I'm going to take this middle term and do the b divided by 2 quantity squared. So I have x plus 1 now, quantity squared. So if I add 1 here, but notice I have this 2 on the outside. So guess what? 2 times 1, I'm really putting a 2 on the left-hand side because I'm distributing this 2 times a 1. So if I put a 2 on the left-hand side, a 2 goes over here. This is the a value, on the side of a value, but the c value times the number in front. Okay? And that needs to happen in order to balance out. So now we simply have 2 times x plus 1 quantity squared equals 32. And now how do we solve? Well, first step is to get rid of that number in front. And we have x plus 1 quantity squared is equal to 16. Take the square root of both sides, plus and minus. X plus 1 is equal to plus or minus 4. Move the 1 to the other side. Oops. Erase that there. Move the 1 to the other side. And then simplify. So x can equal either 3 or negative 5, either one. So that's how we're able to get those answers. So the only difference in this problem is this 2 in front of the problem. Let me just view out here, and so we can see the whole page. And there it is there. So if you want to take a look at all together. All right. What I want you to do is work on this page of problems here. I have 3 problems. Notice the first 2 has a leading coefficient of 1. The last one has a leading coefficient of 3. So you have to factor that one out. I went ahead and put the answers so that way if you check your work, you could see if you got it right or wrong. Okay, so let's go ahead and look at those after today's lesson, and we'll talk about that our next period. Thank you very much, and have a good evening.